Hi everyone. Welcome to Tech Time with PK. Today, we're going to learn how to create a load balancer on OVH Cloud. But before we dive into the how, let's first understand what a load balancer is, and more importantly, what problem it solves. Let's start with a basic scenario. We have the internet, and we have our server. There's a user who needs to access the application running on that server. In this simple setup, the user sends a request, and the server responds. Everything works just as expected. Now, suppose the number of users increases significantly. As more and more users send requests to the server starts to get overloaded. When this happens, it may slow down, or even fail to respond to some requests. To solve this issue, we will add more servers. But that brings up an important question. How do we distribute the requests across these servers? This is where a load balancer comes in. A load balancer sits between your users and your servers, and it intelligently distributes incoming traffic across all available servers. This helps ensure that no single server is overwhelmed, improves performance, and keeps your application reliable and scalable. Now, what happens if one of the servers goes down? If the load balancer continues sending requests to that server, those requests will fail, just like before. To avoid this, load balancers come with a feature called health checks. Let's take a look at what health checks do, and how they help keep your application running smoothly. Health checks work by sending requests to each server at regular intervals. If a server responds correctly, the load balancer marks it as up. But if a server fails to respond, the load balancer marks it as down, and stops forwarding requests to that server. It will only start using that server again once it comes back online and passes the health check. So even if a server is down, the users won't be affected, because their requests will be routed to the healthy servers. And that's the core idea of how a load balancer works. Now, let's move on to the practical part, creating a load balancer on OVH Cloud. To do this, we first need to set up a private network and a gateway. In this video, I'll be using the same private network that I created in my previous tutorials. If you're not familiar with how to set up private networks or gateways on OVH, I recommend watching those earlier videos for a better understanding. I've added the links in the description below. Let's take a look at a diagram that describes what we're going to do in this video. First, we'll create a gateway for our private network. Then, we'll create a few private instances, and set up web servers on them. Finally, we'll create the load balancer and link the private instances with it. Alright, let's get started. First step, creating the gateway. Head over to the OVH Cloud console. From the left-hand side panel, click on Gateways. This will take you to the gateway configuration page. Since we don't have any gateways yet, click on the Create a Gateway button. Now let's configure the gateway location. Our private network is set up in the 1AZ region, in London, so we'll select the same region for the gateway. Click on Next. For the size, I'm selecting Small. Next, enter a name for the gateway. I'm calling it My Gateway. Then, choose the private network. I'm selecting Test Private Network from the list. Finally, click on the Create a Gateway button. Our gateway is now being created. Do not refresh the page, OVH will automatically redirect us to the gateway configuration page once it's ready. Our gateway has been successfully created, and OVH has assigned a public IP to it. Now, let's go back to our diagram and see what's next. We've completed the gateway setup. Next, we need to create the private instances. Let's head back to the OVH Cloud console. From the left-hand side panel, click on Instances. This might take a moment to load, so let's wait. Alright, we're now on the Instances page. Click on the Create Instance button to start the configuration process. For the model, I'm selecting D2-2 from the Discovery series. Since our gateway and private network are in the 1AZ region, in London, we'll choose the same region for our instances as well. Next, it's time to choose the image. I'm selecting Ubuntu 24.04. And for SSH access, I'm selecting the SSH key I had already added. Next, we need to configure the number of instances we want to create. For this setup, we need 3 servers, so I'm setting the instance count to 3. Now, let's choose a name for the servers. I'm entering private instance here. Next is the network configuration. Since we're creating private instances, I'm selecting private mode. Then, choose the private network. I'm selecting test private network. Next, we need to configure the billing. Since this is just a test setup, I'm selecting hourly billing. Now, click on the Create Instance button. A pop-up will appear, letting us know that the instance creation will take a few minutes. Click on OK, Continue to proceed. As mentioned, it'll take a few minutes, so let's wait while the instances are being created. Our 3 instances are now being created. You can see them listed here with the status set to creation. Let's refresh the page to check their status. And there we go, all our instances have been successfully created, and their status has changed to enabled. Now, let's go back to our diagram. Next, we need to set up web servers on these instances. But since these are private instances, we can't SSH into them directly. To access them, we'll need to set up a Bastion host. We'll do this by attaching a floating IP to private instance 1, and use that instance as our Bastion host to SSH into the other 2 servers. Let's head back to the OVH console and create a floating IP for private instance 1. From the left-hand side panel, under Network, click on Public IPs. Currently, we don't have any public IPs, so let's create one by clicking the Create a Public IP Address button. Then, in the configuration options, click on Floating IP. Next, choose the location configuration. Since our instance is in the 1AZ region, in London, we'll select the same. Now, select the instance you want to attach the floating IP to. I'm selecting private instance 1 from the list. For billing, I'm going with hourly. Finally, click on the Create a Floating IP button. OVH is now assigning the floating IP to our instance. Let's refresh the page to check the status. And there it is, the floating IP has been successfully created and assigned. As you can see, it's now attached to private instance 1. Now, let's SSH into the server. I'm copying the floating IP and heading over to the terminal. Let's SSH into the server using the SSH command. I'm using the same SSH key that I added earlier. We're now logged into the server. Next, we need to set up the Nginx web server on this instance. First, let's update the package list by running sudo apt update. This will take a few seconds to complete. Alright, the update is done. Now, let's install Nginx by running sudo apt install nginx y. And there we go, our Nginx server is successfully installed. Now, let's edit the default web page of our Nginx server. The HTML file is located in the var www.html directory. I'm using the Vim editor to make changes, but feel free to use any editor you're comfortable with. This is the default HTML page that's shown when you access an Nginx server. Let's replace the title and heading text from Nginx to Server 1. This will help us identify that it's this server responding when we later test the load balancer. After editing the HTML page, let's save the file and exit from the terminal. Now, let's check if the changes are reflected. We'll start by getting the IP address of the server using the IP address command. Copy the private IP address and use the curl command to test it. And there it is, we can see the response from the Nginx server. The page now shows Server 1, confirming that our update was successful. Let's go back to our diagram to see what's next. Our first server is ready. We'll use this server as a Bastion host. That means we'll connect to the other 2 servers through this one, since they don't have public IPs. To do that, we need to copy the SSH private key to this server, so we can log into the other private instances from here. Let's head back to the terminal. We'll start by exiting from Server 1. Let's copy the SSH private key to the server using the scp command. The key has been successfully copied. Now, let's SSH back into the server and verify that the key is there. Type ls to list the files. Our SSH private key is now on the server. Next, let's go to the OVH console and copy the IP address of our second server. Click on Instances from the left side panel. This will take you to the Instances listing page. Now, let's copy the IP address of private instance 2, which is our second server. Once copied, let's head back to the terminal. Let's SSH into the second server using the IP address we just copied. As you can see, the hostname is private instance 2, so we've successfully connected to the second server. Now, let's run sudo apt update to update the package list. The repository has been updated. Next, we'll install Nginx on this server by running sudo apt install Nginx. Nginx has been successfully installed. Now, just like we did on server 1, we'll edit the default HTML page located in the var www.html directory. As before, I'm using Vim to edit the file. You can use any editor you prefer. Let's replace the text Nginx with server 2 in both the title and the heading. Once the changes are made, let's save and exit from Vim. Let's copy the IP address of the second server and use curl to verify that our changes are reflected. And as you can see, the text has been successfully replaced with server 2. Next, we need to configure our third server. Let's exit from the second server. Now, head over to the OVH console and copy the IP address of private instance 3. Then, let's go back to the terminal and SSH into the third server. We've successfully logged in, and as you can see, the hostname is private instance 3. Now we need to set up the Nginx server, just like we did on server 1 and server 2. I'm fast forwarding through the steps, since the process is the same. The only change is in the HTML file. This time, we'll replace Nginx with server 3 in the title and heading. Let's get the IP address and check the changes using curl. It's working as expected. We've now successfully completed the setup for all 3 servers. Let's exit from all servers. Now, let's go back to our diagram and see what we need to do next. Next, we'll create our load balancer. Let's head over to the OVH console and start the setup. From the left side panel, click on Load Balancer. Right now, we don't have any load balancers, so let's click on the Create Load Balancer button. First, we need to configure the deployment mode. Since all our resources were created in the deployment mode 1AZ region, in London, I'm selecting the same region for the load balancer. Next, we need to choose the size of the load balancer. OVH offers small, medium, large, and extra large sizes for load balancers. Each size comes with different capacity and performance levels. Let's check the product specifications on OVH's official products page. OVH has categorized the load balancer sizes based on factors like bandwidth and the number of requests per second they can handle for various protocols. Size small is the most basic option. It offers 200 megabits per second of bandwidth. Since this is just a demo setup, we'll go ahead and choose size small for our configuration. Next, we need to attach a public IP to our load balancer. This will create a floating IP and assign it to the load balancer. There are 2 options here, New Public IP and No Public IP. Choosing New Public IP will create and assign a floating IP, making the load balancer publicly accessible. If we select No Public IP, the load balancer will be private and can only be accessed within the private network. For our setup, we'll go with New Public IP. Let's click Next and move on to the private network configuration for the load balancer. Here, we need to choose the private network and subnet. Since we only have one private network, it has already been automatically selected for us. Now, let's click Next to continue with the setup. Now, we'll configure the listener and attach the servers we created earlier. The listener is the endpoint that handles incoming connections to the load balancer. The pool is the group of servers where the load balancer will forward those requests. Click on Add a listener. For the protocol, we'll choose HTTP and set the port to 80, since our servers are running the Nginx web server, which listens on port 80 by default. Let's now select our servers from the list to add them to the pool. Next, we'll configure the health check option for our servers. Since we chose HTTP for the listener, I'm selecting HTTP GET as the health check method. We'll use port 80 for all our servers, as that's where our Nginx servers are listening. Now, let's add our second and third servers to the pool by clicking the plus button on the right side of each. All our servers are now added. Let's click Next to continue. Now we need to enter a name for our load balancer. I'm entering TestLB as the name. Let's click on the Create a Load Balancer button to start the creation process. Our load balancer is now being created. Let's refresh the page to check the status. Our load balancer is now listed here. The provisioning status is showing as creating, which means the load balancer is still being set up. The operational status shows the health of our pool. Right now, it's showing offline, which means our web servers are still being attached and aren't ready yet. The IP address shown here is the private IP address of the load balancer. It will take a few minutes to complete the setup. Let's wait and refresh the page after a couple of minutes. Our load balancer is now ready. The provisioning status has changed to enabled, and the operational status is now online. All servers have been successfully attached to the load balancer, and their health status is showing as healthy. Let's go ahead and check the load balancer details now. Click on the Listeners tab to view the listener details. As we configured earlier, the port is set to 80. Now, let's check the pool details by clicking on the Pools tab. We've configured only one pool, so click on it to view more details. Next, go to the Members tab to view our servers. Their provisioning status is enabled, and the operational status is online. This means all our servers are healthy and active. Let's now go back to the Load Balancer Details page. From the Load Balancer Details page, let's copy the ID of the load balancer. Now, let's go to the Public IPs configuration page to check the floating IP assigned to this load balancer. Let's search for the copied ID in the list. And here it is. This is the IP address assigned to our load balancer. Let's copy the IP address, open a new tab in the browser, and paste the IP in the address bar to test it. We got the response from server 1, that means the load balancer is working. Now, let's refresh the page again. And there it is, now we're getting a response from server 2. Let's keep refreshing a few more times to see the load balancer distribute the traffic across all 3 servers. We've now received responses from all 3 servers, which confirms that the load balancer is working perfectly. We have successfully set up our load balancer on OVH Cloud, and it's distributing traffic just the way we expected. At the beginning of this session, we talked about a scenario where, if one of the servers goes down, the load balancer will stop routing traffic to that server. Let's go ahead and test that now. First, go to the terminal and SSH into our Bastion host. Next, let's get the IP address of our third server. Go to the OVH Cloud console, and click on the Instances page from the left side panel. Now, copy the IP address of private instance 3, our third server. Then, head back to the terminal. Let's SSH into the copied IP address. We're now inside the server. To simulate a failure, let's power off the server. This will make private instance 3 unavailable. The instance has been powered off, and as expected, we've been automatically logged out of the server. Now, let's go back to the OVH console and check the status of our load balancer. The operational status is still showing as online, but it may take a few minutes to update. Now, let's click on the load balancer to view the details. See, the operational status has now changed to degraded. That means one of our pool members is down. Let's now check the pool and verify the member list. Click on the Pools tab, then select the pool we created earlier. Go to the Members tab. As you can see, the status of our third instance is now showing as error. That means private instance 3 is unreachable. Now, let's go back to the Browser tab where we were sending requests to our load balancer. Let's refresh the page a few times to check if we're getting any errors. We're still getting smooth responses from Server 1 and Server 2. This confirms that the health check feature of the load balancer is working perfectly. It automatically excluded the unreachable server and continued routing traffic only to the healthy servers. Now, let's go back to the OVH console and power on the private instance 3, which we turned off earlier to test the load balancer's health check. As you can see, private instance 3 is currently in the off state. Let's open the menu on the right side and click on Boot. A confirmation pop-up will appear. Click Confirm to proceed. This will take a few seconds to complete the boot process. The server has now been powered on, and you can see its status has changed to enabled. Now, let's go to the load balancer's pool and check the member list to verify the status of this instance. The operational status is now showing as online. Click on the load balancer, then go to the Pools tab. Click on our pool, and then open the Members tab. You can see that the status of the third instance has now changed to online, which means it has rejoined the pool and is healthy again. Now, let's send a request to the load balancer and test it again. We just got a response from the third server, which means private instance 3 has successfully rejoined the load balancer. The health check detected that the server is back online and started routing traffic to it again, exactly as expected. And that wraps up our tutorial. We created a gateway, attached a floating IP, launched 3 private web servers, and set up one as a Bastion host. Then we configured a load balancer on OVH Cloud, added our servers to a pool, and enabled health checks. We tested how the load balancer handles a server going down and coming back, and everything worked exactly as expected. If you found this helpful, don't forget to like, share, and subscribe. Thanks for watching Tech Time with PK. See you in the next one.